All right, so this is going to be the chemistry test review. And a lot of the questions kind of repeat in what they're asking you to do. So we shouldn't have to go through each one. Now these notes should be on page 40 and 41. We previously skipped those pages so that they should be blank, and it would be a good place to put your review notes. Alright, so first things first. Okay. Melting point is an intensive property. So if you have a little bit of ice or a lot of ice, the melting point of water ice is 0 degrees Celsius. Okay, that's also the freezing point. But if we have substances that melt at different temperatures, then that tells us that they are probably different substances. Okay. Same thing with the crystal colors, which is actually the answer. The material has different crystal colors. They could very well be different types of crystals. If you have a piece of iron in a block of ice and you put it on your stove and heat it up, you're going to melt the ice, but you're not going to melt that iron. Okay, you'll get it really hot, but you're not going to melt it. Number 2, same kind of things. Magnetism is a intensive property. So if you have a little bit or a lot, iron filings are magnetic. Powder, flour, for example, or sugar is not. So that's a way of separating, using a physical property to separate a physical mixture. Okay. Remember that compounds are chemically bonded and mixtures are physically mixed. C is the symbol for carbon, N is the symbol for nitrogen, O is the symbol for oxygen, and iron is Fe. Subscripts tell you the number of atoms. So for example, here in CaNO3 there's an invisible 1 that tells us we have 1 atom of calcium. So as long as we know that Ca is calcium, we know that A and C cannot be the answer. N is nitrogen, so A and B cannot be the answer. Okay, so that means the answer has to be D without even having to count the atoms, but let's do that anyway. If it's Ca invisible 1, there's 1 calcium. And then inside the parentheses we have NO3, right? So that means I have 1 nitrogen and 3 oxygens inside the parentheses. Then this 2 tells me that I have 2 NO3s. So that means I have a total of 2 nitrogens and 6 oxygens. So the answer is D. Okay. And number 5 is the same kind of thing. I have 1 atom of iron, 5 atoms of carbon, and 5 atoms of oxygen. So that would be 11 atoms altogether. Okay. Hello. All right. So then if we, which of the following is an example of a compound? Copper is Cu, iron is Fe, carbon is C, but water is H2O. A compound is more than one element chemically joined together or chemically bonded. So the only one of these that has more than one kind of element is water. So that's the compound. How many atoms are in C6H12O6? How many oxygen atoms are in C6H12O6? Well, again, it says O6, so there are 6 oxygens. Okay. If we look at number 8, how many atoms, total atoms, are in magnesium hydroxide? Well, it's MgOH2. So once again, we have 1 atom of magnesium And then we have, inside the parentheses, we have OH, one oxygen, one hydrogen. But this 2 indicates that we have 2 sets of parentheses. So that's a total of 2 oxygens, 2 hydrogens, and 1 magnesium. So that's a total of 5. All right. Number 9 is like an earlier question, but a little bit reversed, which is composed of only one type of atom. Well, water is H2O, gold is AU, salt is NaCl, and sugar is C6H12O6. So only one of these that has one thing is gold. It's the pure substance here. It's the element. Everything else is the compound. Number 10. Atoms are the basic unit of matter, is what you should write down. The compound potassium sulfate, K2SO4, is a molecule. All right, so it's a molecule made of atoms. So C and D go out the window very quickly. That leaves us with A and B. 2 atoms of potassium is correct. K is potassium. Sulfur is S. Now there's an invisible 1 beside that S. So that means there's 1 sulfur. So A is the correct answer. All right, here, compounds have 2 or more atoms chemically bonded. There should be a Y there. Elements have all the same atoms. That should say atoms. Oh, that's what I get for going quickly. Right, let's go ahead and fix that. 2. All right, and then mixtures would have different substances, but they would just be in the same container. They're not joined together at all. All right, so A is a compound. We have more than 2 kinds of atoms, and they are bonded together. B, the atoms are bonded together, but they're all the same, so that's an element. And then with C, we have different kinds of atoms, but they're just in the same container. That's a mixture. D is, they're all the same, so D is an element as well. So B and D are both elements because they have the same atoms. Number 13, now you might not know what vinegar and bronze are, but you should know that air is a mixture, and you should know that salt water is a mixture. Okay, so mixture would be the answer there. All right. A scientist placed a sample of lithium in a container of water. The scientists observed that lithium is floating and making a buzzing sound as gas bubbles are formed around it. So the observation is the chemical change took place. So what you need to know, what you need to write down, are the signs of chemical reaction. Okay, bubbling or gas production, new substances formed, color change, precipitation formation, or a change in temperature. Okay, so that's what you need to write down there, and that actually goes for the next few questions. Okay, they're all kind of the same thing. Whether or not these are application questions, so they're asking you not just to remember the information, but to actually use the information. All right. Remember, a physical change does not change the identity of the substance. So if you're looking for a physical change, you're looking for something that started out as something and ended up as the same something. So for example, if I have a glass bottle and I break it, it's still glass. So that's a physical change. All right? Mass is always conserved. Whether it's a physical change or a chemical change, mass is conserved. If I measure the mass of the dry ice and then I measure the mass of the gas produced by the dry ice, which is just CO2, it's solid CO2 or gaseous CO2, the mass is going to be the same as long as I collect all of the gas. If I start with 100 milliliters of water over here and I boil it, I collect all the vapor and let it condense over here, I should have 100 milliliters of water over here as well. Okay? Both groups will have the same mass in which they started. So again, mass is conserved. Here, when frozen carbon dioxide is heated, it changes directly into a gas. Why is that a physical change? Because heat causes a change in state. Changing the state of matter is a physical change. These three you should recognize as signs of a chemical change. All right? So that pretty much goes through all of it. So the stuff I typed out to the side, that's what you should have in your notes and what you should study for the retest. Tuesday, which is tomorrow from my perspective, I will give you a progress report. Remember, you can make up work on that progress report. And I will give you a schedule where you can sign up for retest. All right.